Okay, so we got to use the vertex and intercepts to sketch the graph of this given quadratic function. And then we'll state the axis of symmetry and the domain and range. So now, if you don't have the graph, and in order to produce the graph, you're going to need some points anyway. But if you don't have the graph, you're going to need the vertex anyway to define the range of a parabola. If you consider what the vertex means, right? The vertex is either the high or the low of a parabola. And in this case, this parabola opens up, right? Because it's got a coefficient of a positive 1, a positive being what's important. So it opens up. So the vertex is this point right here, right? The bottom in this case, the turning point where the parabola reaches a minimum. So since the range is the vertical component graphically, or what would be considered the output, you can see that the range of a parabola is limited, right? It only goes down in this case so low. So let's start by finding that vertex point. So the way to get the vertex point is, we call it HK, but it is just an XY pair. We just call it HK because it's a special pair in the sense that it's the vertex. So the way to get the H, which is the X component of the vertex, is the negative B over 2A. If you ever take a calculus class, you'll see where that comes from, this formula here. But we're going to use negative B over 2A. And then K is just going to be plugging in B, right? K is equal to, not B, sorry, H, F of H. So let's see. H is going to be negative B, so we're talking negative 6 over 2A. So since A is just a 1, the coefficient of the quadratic term is a 1, 2 times 1 is 2. So the H is negative 3. So we get negative 3. And then if you plug negative 3 in, let's see, we're going to get 9 here. And then we subtract 18, so that takes us to negative 9 plus 5 is negative 4. So negative 3, negative 4 is the vertex. And if you notice, that's actually one of the points they want you to use to sketch the graph. It says use the vertex, and then it says intercepts. So when you go and get this graph, right now we know we're talking negative 3, negative 4, so something like right about there. Be a little bit more precise when you graph it in the homework, of course, because you have that tool. Right about there. And now we need some intercepts. Now I think you only need like 1 or 2 other points if you click the parabola tool in MyLabs Plus, but I'll help you get a few points as far as intercept. We'll get all the intercepts. So the easy intercept to get is the y-intercept, because all you have to do to get the y-intercept ever is to make x 0. And if you notice, when you make x 0, we get 0 squared plus 0 plus 5. So 0, 5 is the y-intercept. The x-intercepts, you can make y 0. And if you notice, if I make y 0 here, this isn't that bad of a solution. We'll just get this thing factored. And y is f of x. I made the f of x or the y 0. This is x plus 5, x plus 1. 5 times 1 makes the 5. 5 plus 1 is 6. So we get x is negative 1 and x is negative 5 as intercepts. So we've got negative 5, 0, and negative 1, 0. So I don't know if you're going to need all 3 of these points. It'll fill in the parabola. Whenever it's done, it'll let you know. But, we do have a point here. We have a point right about there, and negative 1, and then there's 5. So it looks something like that. General idea of the graph. Okay, so we took care of really most of the problem. All that's left is the axis of symmetry. So the axis of symmetry is just the vertical line that divides the parabola in half symmetrically over that vertical axis. So it's always going to be x equals whatever h is. So in this case, our h was our negative 3, the x component of the vertex, negative 3. So the axis of symmetry is the equation x equals negative 3. You need the x equals part in there. The domain for all parabolas is always going to be all real numbers. You can go from negative infinity to infinity. Right? It's a parabola. There's no reason why we can plug anything we want in to be squared, right? We're not dividing by anything, so we don't have to worry about dividing by 0. We don't have to worry about taking the square root of a negative or anything. Anything can go in for x, so the domain is always. You can also view that via the graph. You want to read the domain left to right. So if you see that arrow just going out to the left, it goes up, but it also goes to the left out into forever, and it also goes to the right out into forever. So from left to right, we have no constraints, so we're going from negative infinity to infinity. Now the range is the output, which is the y-axis, the vertical component. So this is what I was mentioning earlier. The range is restricted with parabolas, right? Because in this case, there's a bottom point, right? the lowest point this function ever gets to in terms of y is that -4, right? It does get to -4, so you want to include the point -4, but it never goes below -4 in terms of a y value because it turns back up. So we want to go from -4 into infinity for the range, right? If it was a downward parabola like that, then we would be doing something like -infinity up to 4, because it would be a parabola that looks like this, right? But in this case, it has a minimum. It never gets any smaller than 4. So the range is, or -4. So if the range is from -4, and then it just goes off into infinity because it can be as big as it wants. So that is the entire problem. And it says, it even says use the graph to determine the function's domain and range. So once you have the graph, you really can just read this horizontally and vertically, right? -infinity to infinity, domain, it's horizontal, range, -4 to infinity, that is the vertical. So that's that problem there. Hopefully it helps. If you have any questions, let me know. Thank you. Bye.